Hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem. Is it a tree? So we'll be given an undirected graph of n nodes and m edges. Return 1 if the graph is a tree, else return 0. Okay. So when can we say a graph is a tree? So there are few conditions. So one of them is the number of edges should be n minus 1. Okay. Where n is node, where n is a node. Okay, so there should be n minus 1 edges. Okay, second is all the nodes should be connected. Okay, all nodes should be connected with each other. Okay, and third is there shouldn't be a cycle, that is it should be acyclic. Okay, there shouldn't be a cycle among the nodes. Okay, okay, so let's take this example, right? So what it is saying, 0 1, right? 0 and 1 are connected, then 1 and 2 are connected, and 1 and 3, there's a connection between 1 and 3. So if you see, right? So see, if you see, all the nodes are connected with each other, right? If you start with any node, you will reach to any node, right? This is one condition. Second is there are how many? One, two, three edges, and how many nodes are there? Four nodes are there. So it is following, right? N minus 1 edges, we have n minus 1 edges, 3 edges, right? Okay, and also there's no cycle in here. There's no cycle. Okay, there's no cycle. So let's see another example. So this is a tree. Okay, let's see another example. 0 1, right? And then 1 to 2, and 2 to 0, 2 to 0, right? 2 to 0. So here if you see, there's a cycle formed. There's a cycle formed. So this is not a tree. Okay, this is not a tree. So, okay. So now let's come to the intuition, what we are going to do, right? What we are going to do is we are going to first check whether, right, what is M edges, right? Whether there are n minus 1 edges or not, right? Whether there are n minus edges or not. If they are not, then we'll return 0. Second, this is first. And second, we are going to check, we are going to run a DFS for this graph. Okay, whatever the graph is, we are going to run a DFS, and we are going to count the number of connections. Okay, count the number of connections. If the number of connections is equal to the number of nodes, then we'll say it is a tree. Okay, and yes, definitely when we run DFS, then it will also check for cycle. Okay, so let's see the code. Okay, it's a simple code. So first let's see the Java code. Okay, so here we are checking, right? M is the number of edges, right? And n is the number of nodes. So as I said, the first condition to check will be whether m is equal to n minus 1 or not, right? There are n minus 1 edges or not. If not, then we'll return false. Okay, this is not a tree. Okay, then second, what we are going to do, we are going to create an adjacency list because we are given edges, right? So we want to create an adjacency list. So here we are creating the adjacency list. We are adding, right, u to v and v to u, because it's an undirected graph, right? Undirected graph, it's not a directed graph. That is why we are connecting 0 to 1 and 1 to 0 for an example. Okay, and then once created, right, we'll have this visited boolean array, right? We'll initialize with false, and then we'll have a count variable. Okay, we'll have a count variable for counting the number of connections, right? And here we are running, if you see, we are running DFS here. We are passing adjacency list and boolean vector, visited vector, right? And the count and the start node. We are starting with 0 node. Okay, so here what we are doing here, we started with 0 node. Okay, so we are marking 0 node, or whatever that I node, we are marking it as true, that is visited. And then we are incrementing the connection, right, with the count. We have incremented the count, and then we are now going to traverse the neighbors. Okay, traverse the neighbors, right? So here if you see, if it is not visited, the neighbor, if it is not visited, then we are going to run DFS on that neighbor. Otherwise we won't run, right? So in this way we are going to calculate the number of, right, the number of connections, right? And then, right, in this way we are going to count the number of connections. Then what will happen, if you see, right, we are checking whether the number of connections is equal to n or not. If it is, then we'll return true. Okay, so this is a solution in Java. Now let's see in C++. So this is a C++ code. Okay, first we are checking whether we have n minus 1 edges or not. If not, then we'll return 0. Then we are having this this adjacency list, right? In this way, we are creating the adjacency list and we are adding, right? 0 to 1 and 1 to 0 for an example. And then we are having Boolean array, right? Boolean array, visited array. We are initializing with as false, definitely. And then we are running DFS, right? So DFS, again, the same thing, right? We are visiting, marking that node as visited, incrementing the connection, right? And traversing the neighbors, checking the neighbors. If they are not visited, then we will run a DFS on that node. Okay, in this way, and then we are checking here c equal to n, right? Then return 1. So this is a solution. Let's submit it. So yes, it is accepted. Thanks for watching. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.